Good afternoon. This is Mr. McMurray, and we're here talking about the concentration of substrates and enzymes lab, which is one of two that is on this chapter. So, um, basically, it talks about the idea where enzymes work. You have a substrate, usually be like two pieces that come together at the enzyme, and it hooks them together and speeds up the reaction. Okay, and blah blah blah. We talk more about that in the lecture, but okay. Now, this particular lab, here's what we're doing. All right, we have some hydrogen peroxide type stuff here. And right in this one, we have a test tube full of it. We're going to have a little stopper that's going to go on top of that. Bubbles go down here, and the bubbles go through the tubing and inside this test tube. The test tube is full of water, so as the bubbles come, it will push it down, and you can measure how much oxygen is being produced. Okay, notice there's several different concentrations of enzyme. There's also substrate. We will not use the substrate one, so don't worry about that. There is a place for that, but I took it out, so we won't have to worry about that. We're just going to worry about the other enzyme concentration. All right, now, and the substrate content. Okay, bam. We will move on here. Okay, so first of all, it asks you to identify some things. Those are pretty straightforward. This is just kind of talking about how it works, basically. Okay, so let me put it on here, and I'll just start it going here for a little bit, and we will start it. And a couple tools you'll need to do is click up here on the tools. You will have the you have a ruler. Sorry, I should have just done it first. You have a ruler, which it will set over here, hopefully about where you need it. Mine's taking a while here, okay, but that's realistic, I suppose. All right, so we'll also have a stopwatch. Now, they have done a pretty good job, but you might want to check just to make sure that if you set it to 0, okay, boom, like so, this is about when they've added the hydrogen peroxide to this mixture, and then they put or the catalase into the mixture, and they get the top on. So you can start at 0. Their 0 will work, so you don't have to reset your thing like you do sometimes. But notice 0 is right here at the top. Notice there's a just reminder that well, actually it's going to stay there. That's good. They got it set there where you can't move it. All right. Keep in mind there's going to be a meniscus or a curved line as the reaction occurs. So if you were going to measure a certain time, it would be nice if there were no bubbles at that time. But anyhow, you are going to use the bottom of this curved line. So right there would be just a little bit over 3. 1, 2, 3. I would just say 3 milliliters. Okay, and so forth. All right. Now, and since the ruler will stay there, then you can just keep doing that, and it will tell you at what seconds you need to take readings for that. Okay. So, for example, the first one. Now, there is a little section here. What can be changeable and what can be measurable. I kind of argue a little bit with some of those, but that's okay. The good news is you have infinite number of submissions, so keep playing with that. There's one of them's a little tough to do, but think about which things can you change and which things are in this particular experiment, and which things are what you're measuring, okay, and therefore can be measured. All right, so there we go. Think about that. All right, now going here, it tells you the first time you're going to set it up to 1.5 concentration of the substrate. So you go to substrate, change it to 1.5, and load that. Okay, and it talks about the ruler 0. I think it pretty well does that for you. And this, like I said, the stopwatch is already set at 0 at the beginning. So if you can just go to 20 seconds, and then it wants you to measure the amount of oxygen that's in the tube here, and you'll put that answer there. If you're close enough to the right, it will let you go on. If not, you'll have to go back and remeasure again. Okay? All right. Now, part 2 is how, as you add the enzyme, when does the reaction happen the most, and when is there the biggest reaction happening? So that's kind of what you're trying to figure out here. All right. So basically, this is going to be the same setup as before. You're going to do continued collection of data. It's going to say 40 seconds. So this time you go to 40 seconds, okay, and put that there. And then the same thing at 60 seconds. How much is the total produced in 60 seconds? 80 seconds, okay, and so forth. 100 seconds, 120 seconds, 160 seconds. Okay, boom, now you're done. Now the good news is when you do that, it will give you a graph over here. Okay, I didn't do it because then it would give you the graph what it's supposed to look like. Okay, so I didn't do that. But based on what you see there, then you're going to answer some questions about it. And it wants to figure out the rate of change. Okay, not to make you go into panic over math lessons, but this is basically slope. So it's the y-axis, which is the amount of oxygen produced, divided by the x-axis, change on x or time at the bottom. Okay, so basically, in terms of x and y, then it's going to be y minus, or y2, the final y, okay, what it ended up being, say after 20 seconds, then after 20 seconds minus when you started it, which is say 0 seconds, the y1, and then it's going to be divided by, oh, I'm sorry, I did that backwards. That would be the oxygen produced at the end. Say you go from 0 to 20 seconds, so you put the 20 seconds first, that'd be the y2 minus the amount of oxygen there was when you started, okay, which would be 0. Because you didn't have any when you started. Then time would be like 20 seconds, which is when you stopped, minus, put a little minus sign in there, x1, okay, which would be the time when you started. Okay, and then you click that, and it shouldn't tell you that it's correct. Okay, but I want to give you that formula later just because we haven't really gone into that in class. All right. So a little bit of math there. Now I want to put in terms of milliliters of oxygen. Okay, and it says there were 0 milliliters at 0 seconds, and now you want to how many milliliters of oxygen there are at 20 seconds, or 40 seconds, excuse me. So once again, your rate of change would be however many milliliters you ended up with. Now it will give you that as an option. One of these places that says student response will put whatever you measured and entered up there. So don't panic, it won't say student response, it'll actually put what you did. So you say, well, how many milliliters you ended up with of oxygen at 40 seconds minus how much you had at 0, which of course would be 0 milliliters of oxygen. But just keep in mind that second one letter there is going to be the milliliters of oxygen. Okay, and then the same thing down here is going to be time, the final time, which was 40 seconds, minus the initial time, which in this case was 0 seconds. Okay, all right. And of course, the beginning oxygen would have been 0, and then whatever your answer is there, and that will calculate the formula. Now, when you do that, you can calculate it on a calculator or whatever. All right, and put that answer in here. Now, notice it says 3 decimal places. Okay, so do it 3 decimal places there. Okay, then the same thing. You're going to go from 40 to 80 seconds. But notice that it will, now you're going from 40 to 80. So it's still going to be 40 seconds on the bottom. When you do 80 minus 40 seconds, it's going to be divided by 40 seconds. But this time, it's going to be by how many milliliters you had at 80 seconds minus how many you had at 40 seconds. Now, if I had written this information in here, the good news is there would be dots. Just like this one says at 0 seconds, there were 0 milliliters. If you go over here to 40, it will tell you how many milliliters were there. Okay, and if you go to 80, it will tell you how many milliliters of oxygen was there, and you won't have to go back and look it up. Okay, so you can just do on these dots. Now, keep in mind, there's going to be some dots on here that you may not have measured. Okay, and so make sure you get the right one. There may be one for 20 seconds, even though it doesn't ask you a question about 20 seconds. So make sure when you're looking at this that you're actually on the right one. All right, then you're going to do the same thing, see what the rate would be from 80 to 120 seconds. So once again, how much did the milliliters of oxygen increase from there, divided by 120 minus 80, which is 40. So it's going to be divided by 40 because we're doing this at 40-second intervals. Okay, and then from 120 to 160. Okay. Now, once you get this information, the rate information, it will give you that information in the chart over here. It will not make a graph, but it will ask you which of these graphs would this information look like if you were to graph this information on a chart. It is not asking you about this graph up here. It is asking you if you put this information, the rate information, in a graph. Okay, so keep that in mind when you answer that, because otherwise it may be kind of tough to do. All right, then basically tell what happens is the increase, decrease, whatever. All right, and basically when was the most reaction occurring or the highest rate. Okay, identify the relative time, blah, blah, blah. Okay, if we want to figure out where it's really happening, where would we measure it at, and so forth. Okay, then here you take these different chemicals, tell me if they were an enzyme, a product, or the substrate that's being acted on. Then you would tell me what they did. Did they decrease during the reaction? Did they stay the same? Did they increase? All right, and then you'll have some choices about what you think, your claim of what you think is happening, and then which things and the evidence of this backs that up, and then what would the reasoning be that says, oh, well, this is why we think that proves our claim, and it gives you some choices there to choose from. Okay, that's pretty straightforward. Now, this one's going to be a little different. We skipped a part about substrate concentrations. Don't worry about that. What if we change the amount of enzymes that we're using each time? Okay, and that's kind of what this one is all about. Okay, so once again, you have this formula here. You have enzyme concentrations. The substrate is always going to be 3%, so that's not going to change. What you're changing is how much of this enzyme or catalase are you going to add to the solution, H2O2, to make it break down into oxygen bubbles. All right, so notice this one, you're using 0% enzyme first. So we click on 0 and then load that. Okay, and you want to put how much would it produce after 30 seconds. And you would look that up, measure it off the video, and put that answer there. Okay, now the next one, you're going to use 1.5% enzyme and do the same thing. After 30 seconds, how much did it make? Okay, now the next one wants to know the total for that 1.5% enzyme. Okay, so now you just run it all the way to the end of the experiment and say how much did it produce total at the very end. Okay, then you're going to do 3%, do it after 30 seconds. Then you're going to do 3% and do it at the very end. Okay, and you see this trend here, 6% after 30 seconds and 6% at the very end, and 9% finally at 30 seconds and at the very end. Okay, now it's going to give you some graphs. Okay, but obviously we don't have that yet because I have not actually done this experiment, or at least I'm not doing it while you're watching here. I have done it, but not while you were watching. And so once again, based on your graphs that you end up with from your data that you did up here, you're going to, once again, pick a claim, come with evidence and reasoning that supports that claim. Okay, and this one's about total amount of the product. Is it affected or is it not affected? All right, and that's basically it. Okay, let's see, is there anything else I need to say? I don't think so. Other than that, enjoy, have a good time, and may you catalyze a great reaction, I guess, or have a good reaction to your catalyst. Anyhow, whatever. Enough of that. Have a great day, and hopefully everything will go really smooth.